Hello, this is Sabir Malli. The topic of our discussion in this video is how to calculate the antiderivative of a function. Let's first understand what are antiderivatives. So if you have a function x square and if you calculate the derivative of this function, you get 2x. So what is the antiderivative? Antiderivative is a process which reverses the derivative process. That what we ask is what is the function whose derivative is 2x. So this process called antiderivative. So suppose if the function is 2x, then we ask what was the function whose derivative is 2x. So what is the antiderivative? That is x squared. And you can see that if I add a constant, if I take the derivative of this function, that will also be 2x. So this is a more general antiderivative of this function because this is always end up of 2x. So what is the definition of the antiderivative? The definition of the antiderivative is simple. If you calculate the derivative of the antiderivative, you will get the function back. So this is our definition of our antiderivative. As you can see in this situation, if I calculate the derivative of f prime of x, I will get 2x plus 0, the derivative, the constant, which is the original function f of x. So the antiderivative is the reverse processing of derivative. So once you compute the derivative function and you want to see what is your function, so you have to find the reverse process. That is called the antiderivative process. So let me fix some notation. The antiderivative is denoted by this squiggly sign fx dx. The antiderivative of that function basically is fx plus c. For example, what is the antiderivative of 2x dx is x square plus c, because if I take the derivative of this function, I will get the function which is sitting inside. So this is always you basically ask yourself that if you take the derivative of that function, will you get the function which is sitting inside of that squiggly sign? And also you can verify your all the answer through that. So one more example, let's say what is the antiderivative of x cubed dx? That will be x to the power 4, 1, 4 plus c, because if I take the derivative of that function, if I take the derivative of this function, we will get 4 times 4 is a 1 and 4 minus 1 is 3. So I will get this function which is sitting inside of that. So therefore, the antiderivative of x to the power 3 is 1, 4, x to the power 4 plus c. I think based on this analysis, we can have some formulas, some basic rules of the antiderivatives. So here are the first basic rule, which is the power rule. So if you have a function x to the power n, it is antiderivative. You will compute, you add the power 1 in the exponent, and then you flip the exponent. For example, let's take some examples. So if you will compute x to the power 7, the antiderivative of this function, d of x, will be x to the power 8, and then you flip the power, which is a 1 over 8 plus constant c. Let's calculate the antiderivative of 1 over x squared dx. You can calculate the antiderivative first converting that function into a power function dx, and then you add 1 in the power. If you add 1 in the power, we will get basically negative 1, and then you flip -1. So in -1 over -1 plus constant c. So the antiderivative is just -1 over x plus c. So you will notice one thing. So you notice, Andy, if I calculate the antiderivative of x to the power -1 dx by using the power rule, so what I will end, when I add 1, I get 0, and I flip the 0 and then c. So it means this is not correct. So this is a misconception among some students. Sometimes they try to take the antiderivative of the function x to the power -1 by using the power rule. But unfortunately, this is not true, because if n is a -1, you get the 0 in the denominator. So in that situation, the rule is the antiderivative of 1 over x, or x to the power -1, is natural log of x. And also we have the antiderivative of a to the power x is exponential function. So it is basically is a to the power x divided by natural log of x. And since we know that the derivative of this function e to the power x is a to the power x, so their antiderivatives are also same. Let's take some more examples. Example number 1. What is the antiderivative of this function x plus x to the power 2/3? First, you add 1 in the power. If I add 2/3 plus 1, it will be 5/3. And then I will reciprocate the power 3 over 5. And I will add a constant into it. Now, the next question is, what is the antiderivative of x to the power 9 dx? That will be x to the power 10, add 1 in the power, and need to reciprocate the power. Here is a bit more challenging question. What is the square root of 3x to the power 5th dx? Before I calculate the antiderivative of this function, I will simplify. So this is x to the power 5/3 dx. So now I will use the power rule. So this will be x to the power 5/3 plus 1 is a 8/3. And I will flip the 8/3 and add a constant c. One more example. So what is the antiderivative of square root of x? That will be x to the power 1/2 dx. Therefore, the antiderivative is 3/2 2/3 plus c. Next question is, what is the antiderivative of 3 to the power x dx? So since this is exponential function, it is antiderivative will be 3 to the power x divided by natural log of 3. Because you can see that if I take the derivative of this function, what I will get is this is a constant, and the derivative of 3 to the power x is a 3 to the power x natural log of 3. And since it divided by 3, so that will cancel out, you get 3x. So you must have to have denominator a natural log of 3 in order to reverse the derivative of this function back. Let's do some more example. What is the antiderivative of e to the power x dx by using the same rule? So you see that the rule is a e to the power x natural log of e plus constant c, but the natural log of e is 1, so the derivative of e to the power x is e to the power x plus c. So we can use this formula that the antiderivative of e to the power x is e to the power x. Now, what is the derivative of a constant function? Let's suppose 7 to the dx by using the power rule. So this can be also written as 7x to the power 0 and dx. And if I use the chain power rule, it's going to be x to the power 0 plus 1 plus c, and I reciprocate that 1 which is basically divided by 1, and therefore I get a 7x plus c. So as you can see that if I take the derivative of that function, 7x plus c, I will get 7 back. So therefore the antiderivative, the constant is that constant multiplied by x. Let's do one more, x squared square root of x. Again, I will simplify. This will be x squared, x to the power 1/2 dx. Therefore, the antiderivative of this function, first simplify, this will be 3/2 dx. And this will be x to the power 5/2, and this will be 2/5 plus c. So since we do not have so far any product or quotient rule in the antiderivative, so we will simplify before we use any other rule than power rule, exponential rule, or logarithmics, or e to the power x or a to the power x rule. Here is some information about the antiderivative. So the first one is that if you have a constant inside the antiderivative notation, you can pull it out, because the constant time multiplication of the derivative property hold for the derivative, it is also will hold for the antiderivative. For example, if you calculate the derivative of 5x dx, you can calculate the derivative of, you can pull out the 5 and calculate the derivative of x dx only. So that will be basically 5. What is the derivative of x? Is the x squared divided by 1/2 multiplied by 1/2 plus c. So you can see that this is a 5/2 x squared plus c. And we can also verify that if the derivative, we take the derivative of this function, so we will get the function which is sitting inside. Another property is the sum of the antiderivative is the sum and the subtraction of this antiderivative. For example, if you have a function x squared plus x, and you want to calculate the antiderivative of these two functions, so you calculate the antiderivative of the first function, which is 3/1/3, and then you calculate the antiderivative of the second function, which is square 1/2 plus c. The second property says that you can do the antiderivative term by term. The first property says that if you have a constant multiplier to the variable, you just calculate the antiderivative of the variable and you multiply the constant to the antiderivative of that variable function. Let's do some more example. I have two more example here. So first example is we will calculate the antiderivative of this function. So we're going to calculate 1/2 x squared minus 2x plus 6. We would like to find a function whose derivative is this. So first is 1/2 will stay outside. And what is the antiderivative of x squared? Antiderivative of x squared is x cubed. You add 1 in the power and then you flip. So the process is really reverse than what is in the derivative. In derivative, first we drop the power when we subtract. But here when we add 1 in the power and then we flip the power. And then this is a 2 which stay outside. But the derivative of x? Derivative of x is x squared and 1/2. What is the derivative of constant? Constant time x, and we add a constant t at the end. So if I simplify this one, what's going to be 1/6 x to the power 3. 1/2 and 2 will cancel to 1, so it's going to be x squared plus 6x plus c. So now the problem number 2, we wish that we have the product rule for the antiderivative, but we do not have the product rule. So we cannot use the product rule here to calculate the antiderivative of this product. So instead of that, what we will do is, since we do not have the product rule, we simplify the expression in inside of the antiderivative notation. So if I simplify, I'm going to 2x square, I will file this thing out, 2x square, this multiply to this multiply to minus 6, and plus 10 is going to be 4x here, and this multiply to this is the 30. Yes. So therefore, what will be the antiderivatives? 2 times antiderivative of x square is 1/3 x to the power 3 plus 2. The antiderivative of x is x square 1/2, and the antiderivative of the constant is constant time variable plus constant. So if you it's going to be a 2/3 x to the power 3 plus 2x square minus 30 plus c. That is the final answer for that question. Here I have 2 more examples. So let's begin example number 3. First, we do not have again the quotient rule in the antiderivative. So if you get any function which is a quotient, we're gonna simplify first this. How to simplify something like this? So first thing is you can do is you can divide the each term by square root of 1/2. And therefore this will give us 3t to the power negative 1/2. That is a t to the power 1 minus 1/2 is a negative 1, positive 1/2, because the exponent is a 1 and the denominator exponent is a 1/2. So it will subtract when you go into the top, and therefore this one will be t to the power, this will be 2 minus 1/2, which is a 3/2. And now you calculate the antiderivative. This is a 3. If you add 1 into the power, you get 1/2. And this is the reciprocal of 1/2 is 2. And here, if you add 1 in the power, you get 3/2. So this is a 2/3 t to the power 3/2. And then you have addition sign, that will be 5/2. So 2/5 t to the power 5/2 plus constant c. So that will become 6. So this multiply to that is 6. So this is my simplification. In the next step, I will just replace this by 6. So this is the antiderivative of the functions when you have a quotient function. The only right now way of calculating the antiderivative of the quotient function is we have to simplify and turn everything into a power function. Here is a bit more challenging problem. What is the antiderivative of absolute value of the of x? So we know that the absolute value function is either x or is a minus x, is depending on if x is a positive and if x is a negative. So the antiderivative will be basically, what is the antiderivative of this? What is the antiderivative of this? So the antiderivative is a 1/2 x square plus c. This is a minus 1/2 x square plus c. When x is a positive and when x is a negative. So here I have one quiz problem for you get to practice. Once you finish the answer to that problem, you can leave your answer in the link above to compare with the other audience. Here is another quiz problem, which is the antiderivative of the product f prime j is the antiderivative of f times the antiderivative of g. Let me know if it's a true and false by submitting your answer in the link above. Here I have word problems, which we will basically we will see that how we use the antiderivative to calculate um, some word problems, the real word problem. So let's read the problem first. A particle is moving along x-axis. In each case, find the position s of t of the particle. So the velocity of the particle is given v of t, and we would like to find the position of the particle in term of t. So we know that if the velocity is, we know the relation of about if the distance s of t is given and you calculate the derivative of the distance, that gives you the velocity. That means s of t is the antiderivative of the velocity function, because once you take the derivative of the velocity, so in other words, if you take the antiderivative of the velocity, you will get the distance back. So what we will do, so s of t will be antiderivative of velocity. So that's one thing we will use. So what is will be s of t? What is the formula for the antiderivative of 3 to the power t? Is 3 to the power t divided by natural log of 3 plus constant c. We will also calculate this constant c by using this initial condition. We say that at 2, when t is 2, s of t is 9. So this is a 9 when t is 2. So that give us c is equal to 9 minus 9 divided by natural log of 3, which is 9, which is you can simplify as a 9 natural log of 3 minus 9 divided by natural log of 3. So therefore, your final solution is what is your s of t? So your s of t is 3 to the power t divided by natural log of 3 plus 9 natural log of 3 minus 9 divided by natural log of 3. That's your final problem. So yes, if you want to basically reverse back, if you want to go from velocity to distance, you have to take the antiderivative because you have to undo the derivative of the. Here I have the acceleration. So you know that the relation between the distance, if you take the velocity and the acceleration, if you take the derivative of the function, you get velocity. If you take the derivative of the velocity, you get the acceleration. So in order to go back, I have to take the antiderivative to get a velocity, and then take the antiderivative to get distance back. So I have the acceleration. I will start from the acceleration is a 2t plus 5. So the velocity of this will be the antiderivative of this, which is a 2 times t square times 1 half plus 5t plus a constant, because there is always a constant, multiply there. So this is a t square plus 5t plus c. That is the velocity, general velocity of the function. Since the initial velocity is -5, so this is a -5 when t is 0. 0 square plus 5 times 0 plus c. That gives me c is equal to -5. So therefore, my velocity function is v of t is t square plus 5t. Now, if I take the one more time antiderivative of this function, I will get the acceleration. Sorry, the distance. So s of t will be 1/3 t to the power 3, and this will be 5/2 t square plus a constant c. Again, I have this condition. I will use that one to calculate the constant. So if I have t1, that is the 2, this is going to be a 1/3 plus 5/2 plus c. Therefore, sorry, c was a -5 here. So c was a -5 here too. So I missed that -5. So therefore, the antiderivative of this function will be minus 5t plus c. Okay, so that's minus 5 plus c. So your c will be 2 minus 1/3 minus 5/2 plus 5. So which you can calculate. This is a 6 is a common denominator. So 6 is the common denominator. And this multiply 6 is a 12. This is multiplied 2. This is multiplied 3, 15. And that's multiplied by 6, that is a 13. So that is a minus 17. So this is a 25 over 16. So C is a 25 over 6. Therefore, your distance S of T is 1/3 T cubed plus 5/2 T square minus 5T plus 26 over 6. So this is how you can use the antiderivatives in some real world practical problems. So then you have the velocity of the acceleration is given, you want to cover. If you want to find how much distance you have covered, you basically just reverse the process of the antiderivative. Here I have some more formula for the antiderivative of the functions, which we know already the derivative of these functions. We know that derivative of sine x is cosine x, so the antiderivative of the cosine x will be sine x. So the antiderivative of sine x will be minus cosine x, because the derivative of that function is minus sine x, so minus plus. Derivative of tangent is a secant, so antiderivative of the secant will be tangent. The derivative of secant is a secant tangent, so the antiderivative of secant tangent is secant tangent. And also the antiderivative 1 over x squared plus 1 is arc tangent inverse. And similarly, the antiderivative of 1 over square root of 1 minus x squared. And that will basically be arc sine x plus c. So here we leave many functions that we do not know yet how to calculate the antiderivative. So these are the few functions which we have. So we use these tables basically to find these derivatives. So let's do some examples based on this formula. So what will be the antiderivative of 2 divided by x squared plus 1 dx first? So you can see that the constant can be taken out from the antiderivative notation, this usually sign dx. And we know that the antiderivative of this function from the previous table, the antiderivative of this function is arc tangent of x. So this will be arc tangent of x plus c. If you take the derivative of this function, you will get back whatever is inside of that. And so this is how you can verify your answer. What is the antiderivative of that function? So this will be 2 multiply as it is, and you add 1 in the power. So if you add 1 in the power, you get 10/3. So then you reciprocate this here. And then what is the antiderivative of sine? So the antiderivative of sine is this time minus cosine of x. This is the secant, and the antiderivative of secant square is, you see the antiderivative sine is a minus cosine, the secant is a tangent. So this is just tangent of x dx plus constant. What is the antiderivative of secant x 7 times secant x tangent x plus 1 over square root of 1 minus x squared dx? So again, it's all just identifying the formula. This is a 7 as it is. The antiderivative of this function, if we look into the formula, this is a secant x only. So this is a 7 secant x. And the antiderivative of this formula is a arc tangent us, arc sine x plus constant c. Here I have another icalic problem, so where basically you have to calculate the antiderivative of this function and then calculate the constant, and then you have to calculate the antiderivative again. So you get back to recover the function f back, and then you will find that function evaluated at 0. It's very interesting and challenging problems for you to practice. Here is another problem where the velocity of the function is given, the very similar problems which we did. In this problem, so you have to calculate the this distance or the displacement of the function. Once you complete the problem, leave your answer in the link above to compare with the other audience. Question number 5 is a very interesting problem. If you have given the antiderivative, the graph of the antiderivative function, can you use this notation? Because if you take the derivative of that, you get the function back. Can you get back which will be the graph of the original function whose derivative is there? This is all I have in this video for now. And thank you very much for watching the video. And if you like my video, subscribe my channel and hit the bell